Start. Yes, now the recording started. Today's session we are going to see that is with the inclusion of the transformer and generator and load along with CT and relay function. So if it is time permits and motor effect, we will also going to see on today's session. First of all, we are going to start that the Etap. Now the Etap is started. Are you able to see my screen? Yes.
Yes, sir. Yes, sir.
Yes. So this is that the new file for today file day 2 for PS relay. So PS relay. So I am going to start this file, the new option. So I am going to do the step-by-step procedure what we are going to see in last class. Yes, this is that the edit window. Now I'm going to draw on a simple SLD, and then I'm going to connect the CT current transformer with suitable current ratio and relay unit. How the system which can be the performance, and how can I obtain the that is the diagram for the current setting, right? So first of all, that is the SLD, a single generating unit. This is that one single generating unit. Next, this is the 11 kV power generation. What is the next one is the transformer. This is the transformer. So this is that the transformer is there. So next one is that the transformer. So next to what is that after that this is the 11 kV generation. Next to 11 to 110 kV for the power transmission purpose. This is the transmission line. This is that transmission. So next after that receiving, again we are going to reduce 110 to 11 kV. So this 11 kV to again we are going to that is connect the lumped low. So this is the one single structure, that is the basic structure of power system. So now I am going to connect these modules. So here I am connected for basic things. These basic things already we are seen in the last class. So this is bus here, that is bus 1, bus 2, bus 3 and bus 4. That is which means this is the nodal point. This is that the nodal point, bus and the node. I am going to select this. This is the bus 1. So please here you may going to fix the cursor. So during the time it is unknown. Again that is the bus. If it is bus is coming, again the node will be displayed. See, there is no bus is available in this right click. So however I am going to here. So in last case we are going to find out that this is unknown. Again this is unknown. If it is need, again going to connect, but this is the bus for the bus 1. It's a node of that bus 1. So during that time you may going to select, that is the bus node. Again I am going to select. So this is bus 2. Similarly this is bus 3. I'm going to select bus node of that point. Again, I am going to just touch with the line. So just I am going to touch with the line. So if it is unknown, during that unknown time, there is no bus command is highlighted here. But if you are going to bus is available, the specific node, so during that time the bus node is highlighted here. So this is the another bus. So this is the basic thing already we are seen. Now we are going to give the data for each and every bus nodes, how we are going to given. So now I am going to given. So what is this? This is the generating. So I am also going to give, that is the 100 megawatt. 100 megawatt. So kVA is 11 kVA system. So power factor assumed as for our purpose, that is 80, that is 88. So impedance model based on that typical value I am also given here. Again I am also given OK, right? So next I am also giving the data for the transformer. Here the transformer, this is the T1. So what is that, the in and out? This is the in value. Next rating. So rating, next one is impedance. First you can fix the rating 11 kV. So the second they assume as that is 110 kV. 110 kV. You may going to select the transformer at the same rating of the generator or less than that. Here only the single line I am also going to take as that 100 MVA for the safe transient purpose. Okay. Next, if it is impedance, you based on this value analysis, it is automatically the Etap which can be going to calculate that R and X values. Here that is the typical values we are giving. So again, okay. So we are giving that okay. So next, please see here. That is what is that the 110 kV voltage available for bus. Here that is 110 kV available for bus. This transformer we are not give the rating. So this bus voltage, please see, this bus voltage is 0. So once again I am going to focus this. Yes. Oh. Yes. Now the I think it is visualized. Yes, this is bus 4 is a 0. That is 0 volt. But here that is the 110 volt. Now I am going to give the data. So this is that data, that is the rating. I am also going to give the value of 75 kV due to drawage. Again secondary we are going to assume as 11 kV. 11 kV. So the impedance we are going to calculate the typical impedance value. Yeah, calculate the typical impedance value. If it is tapping and protection issues, we are going to see on later how it can be available and how we are going to take as a protection. See, please see, that is now the bus voltage is automatically updated. So before updating, we are not get the suitable value, but after updating, that is the 11 kV is automatically updated. Now that is that we are going to give the load. Load we are assumed that is only that 25 MVA, 25 MVA megawatt at the power factory is 78. So this is maybe going to change the real reactive power and short circuit calculation. If it is needed, then we are going to give. Right? Okay. So that is that the another transmission line we are seeing here. That is the transmission line parameters. So that is the transmission line we are going to consider. So what is this? The transmission line. Assume that this is on 10-kilometer length, and parameters which is available, configuration parameters. So this is that the parameters assume that is the conductor. So this is that the conductor which is available for the TD. What is that? The transmission and distribution cases which is available for the work, which is available for the work. Next we have going to select the specific library values. Again similarly we are going to select that is the specific value, value as per that is our need. Again we have going to be selected. So this is the normal rating of that the transmission line. So based on the already existing system which can be available. Next the configuration parameters. So assume I am also giving the 2.5 for here. So this is 5, automatically we are given to that the height we are, I am also giving that 7 feet for the, that is, this is for 1. Again I am also, this is for the 4 feet difference. So this is the A to B, B to C, and the ground line. This is 4 feet. This one is height. The entire structure of that the transmission line we are given. So now we are giving OK. So now the data are given into that the system. The data are given to the system. So simply that is the load flow analysis. We are, that is LFR. That is we are run that the load flow analysis. But what is that the problem? Energy buses is less than the 2. Display has to swing. So the system can be energized such cables and impedance, etc. So this is the fault as per that yesterday we are seen. So what is the problem? We are going to select here because this is that the swing bar. Okay, now we are giving. So again we have going to run the system. Yes. So now please see the load flow analysis which can be we are going to get that the output. We are going to get the output of that the load flow analysis. Okay. So this is that the thing already we have seen in last session. What we are going to do in next? So we are going to do that is in the relay based operation. Now I am going to include the circuit breakers. Please see that the circuit breaker here. This is the high voltage circuit breaker. This is low voltage circuit breaker. Again I am going to select the high voltage circuit breaker here. I am going to merge it. That is right. Yes, it is connected. Okay. So once again I am enlarge it. Now it is connected. Right. This is one circuit breaker. So yes, this is circuit breaker. So next I am also going to connect the other circuit breakers if it is needed from that transmission line. That is the transmission line. This is the transmission line is the very high voltage. That is I am also connecting this circuit breaker. Right. So this is connected. Right. So here next point I am also going to connect this higher value of that another circuit breaker. Yes. Yes, it is the CB is connected. Okay. The next part, that is we are going to connect that CB with the suitable what I am says, that is the in the relay schemes. So the relay scheme we need that the what we are going to say. So in the CT current transformer. So this is the current transformer which is available in the block. I am going to select the current transformer and place it here, right? So here I am placing the current transformer. It is connected, right? So again another one CT in the transmission line I am connected. See. This is that the city I connected here. So again that another one city. So this is the another one city I'm going to connect it here. So this is the two cities which is I'm also going to connect this one CB and the another one CB, another one this is the city. Now I am going to connect some other that relay function. We need the relay. So please see, this is the multifunctional multifunction relay. Okay, now I am going to select this multifunction relay. So this the relay which is connected through the CT, right? Again similarly I am also going to connect. Right, so this is the another one point, multifunctional relay. The relay is connected with the through the CT, right? So the next point we are going to consider for the what I am says, this is the point we are going to give that the suitable rating of that transformer. This is the transformer, current rating transformer. Assume that is 400 amps to 5 amps. So I am going to select that the ratio B of 8 into that is 540 at the range of K. So for that 4000 amps, here the 5 amps, that is B of 1.8 ratio. So which is we are given here, right? So similarly that the same rating we are utilized here, that is the CT ratio, that is 405 at is BC of 1 to it. If it is the different range, then how the overlapping is occur in the power system protections coordination, power system protection coordination we will see, right? So this is that the rating. Again rating is that is 4005. So again 1/8. So this is that the input we are obtained the CT1 and phases 400 to 5 everything. The output where we are going to get the output, which is add DOI and add with the HVB circuit breaker, high voltage circuit breaker for 1. This is the event we are added DNF function. So the percentage or high impedance I am going to take in the library. So a library. So different types of manufacturers which is available in this library. switch gear, that is Snyder based operations I am also given. So 300G, the function is a differential and overcurrent, which is available in the market. Suppose if you want to know the basic operation of the relay, directly you can go this website. Directly you can go, that is that the website which is Switchgear Engineering Laboratories. That is some other reasons, event ID, but this is the basic relay concepts and relay things which is available. That is available in the net based on the different vendors. Suppose if you are used in the different vendor for example purpose in the ABB. So the ABB aerobation 50B, ABB in the 50B relay, which is available. It is ABB. So if you are going to find the relays, so next the 50B series. So the 50B series, that is which can be our general information commercial based relays. So the what type of relay which is available in the practical market, we are going to directly inherit that the relay function, that directly inherit the relay function. So suppose if you have that the data sheet, this is the data sheet, we have it how it can be the working, we will see on later, right? So here we are going to choose some other the basic that is the relay operations. Please write. So now I am going to select the proper. Suppose if we are not going to select the proper relay, the relay coordinations, it will create some mal operations. We are not get that is the output is something else difficult to get that the output, right? This 300G. Okay. So now it is a selector. Now it is a selector. So input and output values is selected. Okay. So next we are going to take as that the relay of this relay. So this relay, what is that the input already which is have it. So output I am also going to take on this add. This is for CB2. This is for CB2 and OCR. That is overcurrent relay based system. The library. So as usual, the same relays, the same voltage case. That is the same relay, and 300G. I am also going to select it. So this is the basic relay function I am also selected here. So similarly, this is the relay value input which is given to the system OCR overcurrent relay. Sorry, that the output is we are going to take into output, that is event ID high voltage circuit breaker for 3. This is the 3. Then the OCR, this OCR will be taken into that the library. What is that the relay value? The actual relay values we are going to select the suitable relay values. So these tripping and the standards, everything we are going to be inherited from the specific relay, right? So now the relay ratings also will be selected. So I am also going to do one by one. So this is the entire diagram, right? So now that is please here. Yes. that is visualization is a problem, right? So next we are going to consider what we are going to do, that star protection and coordinations, right? How the star protection in the coordinations will be accumulated. So we want to draw that the star view manager, no other variables is there. There is number of buses is there, but no other variables is available here. How we are going to select that the variable? Now I am also going to taken this the entire system. Entire system will be taken. So please see, now it can be the create the star value is enabled. So whenever I am going to cover all the SLD diagram, which can be enabled, right? Yes. So this is the relay function value. This is the relay. Already we are going to see. Yes, this is that. Yes, are you able to hear me? Hello.
Yes, sir. Yes, sir.
Yes, yes. So that is that. This is the relay. This is the relay, which is that the function, relay function. How the relay, which can be create the coordinators in the sectors. This is the generator. So generator to that is what is which is available the T2, what is the time second period. Next one is the that is the generator operation. Next relay 2. This is the relay 1, which may be going to taken as the higher priority. That is that the next one is that the relay to 2, that is overcurrent based relay. The current, please see the highlighted part. Yes. Yes. Relay to 0.51 OCI switch gear. So it can be highlighted for the time of operation. How long time will be taken by the relay? How long the time will be taken by the relay? So this is the diagram which can be create the primary and backup protection of that the transmission line. Primary and backup protection. Suppose I am also now I am going to simply this is that user car which can be queue about the library, everything already I am also explained how we are going to get display option. So this is the creative report. So the what are the report is created. So this is the settings, viewer and PDF. So now I am also select that the PDF. So everything is selected over current relays. So again I am going to select. It will be open. Yes. Please see the Etap, the project session, everything. So it is the TOC instant. What is the pickup time? 0.1 to 3.2 seconds. The time lag of 0.05 seconds, and phase instant pickup value. So everything that is the OCR, that is the relay which can be how it can be performed. Every thing which can be displayed here. So the entire result the coordination purpose, the coordination of that relay, we are obtained from that the device, different devices for the two relays systems. So what is that? The ground instant time, neutral point clumped, pickup time value. So everything we are going to take into account, right? Suppose at the same time we are going to do some other that is the toggling operations. So this is the entire curve relay. So we are going to take that zooming and non-zooming operation and toggling. So we are going to remove this. This is the relay. How the relay which can be this view I think is more clear compared to last view. So this is the relay coordinated value. So how the relay which can be performed from one option OCR, the next relay will be how it can be deviated from that next relay. So this is that the diagram. Suppose if you want to do the time difference operations of here, we are going to SLD. We are going to that now SLD with the fault operation. I am going to give that the yes. This is the fault. Okay. So please highlight. It can be tripped. Yes. One by one it can be tripped. Please see the generator is lost. Next one is that this relay and this relay is tripped. I am also going to increase that the visualization now. Please see. Yes. Are you able to see that the tripping operation sequence? Reverse sequence. Hello. So that is the relay which can be affected by that any other operation. So how which can be affected and the tripping different tripping sequences. This is the final protection is the first relay. Next one is that the CB2 based relay for what time. Next relay which can be first protection is the relay number 3 is the first protection. Okay. So this is that the view already we are seen in the earlier case. So this is the case we are in the different cases. So how it can be this relay and this one is this one. So different time of operations, how the relay which can be act as a backup protection of the system. Okay, right? Yes. Now I am also going to add this yes, the normal mode. So this is the SLD mode in the edit mode. So now I am coming to that edit mode. So if it is, I am also going to add that the annual transformer and lower voltage braking. How the system will be in the performed. Okay, so I'm going to take as the again two winding transformer. This is the two winding transformer, right? So which is maybe going to connected. Yes, this is the transformer. Again the load which is available here, right? So this load again connected to this transformer. Again this transformer is connected to this. So what is this? I am also going to fix the rating is what is the kVA rating? Is 11 kVA. So the voltage is 0.400, which means 400 volt. The load I am also giving that maximum 1 MVA. 1 MVA load. for in the low voltage side. So impedance we have typically calculated, right? So it can be typically calculated. Then I am also giving okay. At the same time, I am also going to fix if it is any fault is occur, what we are going to do for that breaker. So this is the low voltage breaker I am also going to give, right? So the breaker, so this low voltage breaker, and I am also going to connect with another one CT, right? So this is the another one way how it can be integrated. The next point we are going to how the machines will be integrated for the next choice. So this is the integration point. Again, I am also going to give that the tripping, that is the multifunctional relay I am going to take in here. So connect this relay, right? So this is the thing I am also going to take as the relay. Is a primary is what is 1000 amps, that is the maximum. So 1000 into 10, that is 0.110, 1 of 8, that is 0 of 9 and 2 8. So 1 is to 10, 0 of which is available. So again, this is the breaker. So breaker is the AC analysis side. So this is the base values if you need, and then change open or close positions. So trip devices, if it is in the protection, we are going to change this. We are going to change the protection data, and then how the protection circuit will be deviated. This is the protection curve. So how it can be deviated after changing the data and before changing that the data, right? So this is we are going to take as the lump load. So nameplate is what is 500, that is I am also giving the 0.5 MVA. The power factor is 98. I am also going to rated kV is 0.4. So that is the calculator. This is the calculator. That is the substituted values. This is the substituted values we are going to give of the in our systems. So next we are going to give it. So during that the process, now I am going to create the entire system, that is the analysis, how it can be relay diagram is deviated, because already we have that this type of relay. Now we are changed the relay, that is the function, and relay one operations. So this is the relay coordinations. Again, that is the tripping will be formed. Yes. So please see how it can be deviated from that the last see that diagram. This is the two diagram which is a earlier case. Yes, that is the two relays which can be created one by one. Yes, this relay and this relay and this relay. How the final relay which is available here, lumped load, the breaker which can be going to trip, and then one by one operations. But here that is in the low voltage side only the short tripping. Please see generator 1 where it can be tripping. So this is the point of the generator 1, that is 1 second at the time period, but it can be this area. Please see this area. Yes, I think you may going to visualize this area. The cutting point of the generator is here, that is no load or constant excitation, that is the point is nearby, that is the 4.5 seconds attack. But here that is it may be changes from that in the point of a different point. This is one relay function and another one relay function which can be incorporated, right? So this is that from this way we are going to consider. Same thing we are going to do in that the any fault functions is core, any fault if it is a core in the system, three-phase system. Suppose the fault is a core in this place. Yes. So how the system which can be performed? So that is the entire system will be changes the relay functions and the coordinations of that the relay, and the relay timings will also changes if it is sorry. So this is one nodal point. Suppose if we are not getting, again we are not getting, and then edit mode. So this is the bus 5. Bus 5. We are creating the bus or nodal values for this relay function. Yes. Yes. So this is that bus. Yes. Here the bus node, which is available here. So if it is any faulted based systems, I'm going to select for this operation, and yes. So during that time, so if it is that the fault calculations and everything we have going to consider, so how that the system which can be working in the based on that our working, right? So if it is in the short circuit analysis, next we are going to given us the fault bus on that system, how it can be running. So if it is the relay is given, how that the relay which can be working based on that our requirement. Now I am going to change the entire thing. Yes. Select all, then we have going to take. So please see the combined operations. So operation 1 and the operation 2, this is that the combined operations of relay coordinations. This is the relay coordinations of that the combined operations. Okay, so if it is need that is zoom fit with a SLD, so based on that color, we are going to fix that is which point. Again, we are going to change, right? Or we can zoom in with the diagram how it can be deviated in the section wise auxiliaries we are obtained in the relay functions. So this is the overall view. If it is need to capture the star view or the coordination view, everything we are going to capture based on that our requirement. Simply you can capture and going to the word blank document. Okay. So this is that the function we have going to be available. What is that available in the relay coordinations? If it is need, or if we are going to taken as like this. That is the region I am going to select. Yes, selected as copied. Yes, what I am selected, that portion is copied. So this is if I am select the entire thing, the entire system, which is so based on these relay coordinations only, we are going to select the relay coordination of the entire power systems. The entire system. So next we are going to see that what time says. So I am also closing these relay coordinations externally. That is, I am also going to add in the one motor. So motor performance. So how the motor performance which can be incorporated. So this is on synchronous motor and ordinary motor, which is induction machine, which is available. So now I am going to connect on induction machine from here to this bus, right? So I am also giving that the induction machine rating. So this is the HP. So simply I am also giving that the 100 HP. So the other details which may be going to select MFR NSC standard. So based on that library, or if we are going to use the library, we can select the data, everything data. So impedance values and everything we have going to be selected as per that the model. If you are going to the library model, again library model which is available, different model, but what is the difficulty of this is if you are going to give the proper model, then the system is not properly give the result, and the solution is not converged. But if you going to do in the MATLAB, the MATLAB will also give the any one value. The MATLAB give the what is the your input, it may given as any one value, but Etap will also going to only the real time component based value. That is the different. Now I am also going to do the basic load flow analysis. These load flow analysis already we have seen. So in that the switching function, suppose if we switching function we have going to be used, there is no switching actions replaced in the simulation time. So switching action if you need, again we are going to be fix the switching function. So this is that the switching function in the edit mode, the switching function which is available. So this switching function we are going to ground switch or any other switch double DC double switch. These switching functions which can be incorporated by the in our line, right? So for that purpose, so why I am telling this is a harmonic based studies. Suppose if we are giving, then you can we are not giving the much nonlinear load. So however we are going to given that different types of harmonic analysis. So that is the harmonic adder, the output which may be going to be changes. Right? So we are going to change. If it is changes, so this is not practically that is visualized. That is, if you are going to that the report, in the MS Word. Yes, overhead reactance, what is that the values? But this is that we are not give that any nonlinear loads, higher level loads. So we are not going to get, suppose if we are going to connect the harmonics based loads, during that time how the transformer reactance and overall report analysis will also give the THD value and TDD value, everything is given by that the system, right? So this is the complete system, harmonic load flow analysis, cables and everything. If you need everything or buses, transmission line. So the transmission line, based on that system, we can know devices. If you are going to close the plotter, the device ID will be selected, the frequency plotter. So based on that, the plotter order the devices. So if it is choose the any one device in the angular order harmonic, yes, close. So again that the system which can be working in the output, right? So I am also, why I am telling that is we are going to give the one by one all the values. So arc furnace, but the load is in the different way. This is the motor. I am also giving that the motor loads. Suppose if you are used in the starting analysis, motor starting analysis, something else different for that motor starting characteristics and motor starting analysis. That is the transients, starting transient, how the motor starting transients will be incorporated. So that motor starting transients we are incorporated in the next class. So if you have the any doubt in the today relay coordinations and adding of a circuit breaker, adding of a CT and a low voltage side and a high voltage side, how the system which can be performed, do you have any doubt? You may ask the question. Because that the Etap is entirely is based on that commercial industries, that is commercial consultancy based software systems. Commercial consultancy based software systems. This is Etap which can be working. So for that purpose, I am also slowly moved on one step to another step. Any other queries? Suppose if you have that the problem with any other impedance, wrong value given, the machine is not properly working. Suppose I am also going to change the values. Suppose in the transient performance, please see. That is the transient. We need that the fault analysis, because the transient celebrity action is specificated of the synchronous generator, which is equal to is not given. So these type of troubles which may be given, because I am also not given that transient states. Suppose, and another one thing, I am also going to given that this transformer in the protection issue. So the protection issue, this is the graph already we are seen that I am also going to, if you use the user defined, again the user defined or unsupervised or supervised, otherwise you may going to change this multiplier, which can be changes. Yes. If this changes, again the diagram is changes. So if it is both the frequent or the infrequent, both the thing will be updated. Pin with the disable in the short circuit time, but it is not advisable for that working. In the harmonic, we are not giving that the harmonic, but in the harmonic presence we are going to take in the ABB transformer, and the typical, suppose the ABB we are ACS standard, we are giving that this type of harmonics is presented in the what I'm saying, that in the transformer. So I am also giving the harmonic value. This transformer I am also going to give that some other harmonic in the library, same IEEE standards, that is ABB VN given. So again this thing I am also going to take as the issue of that that harmonic. This is Rockwell type 18 12 pulse. Okay. So this is that type which may going to be, if you need to print again, okay, it may going to print and then taken as that the output. This is the normal. We are going to how much of that harmonic we are going to get. So this is the all the data we are given. So again we are going to that the edit. This is that the edit mode to what we are going to do in the harmonic analysis, right? So now the harmonic analysis order will be changes. There is no plot data to display. You may have selected the no device of a plot. Because if you need that plot, we are going to select that the plot, whether it is we are going to be act as that the device which can be used in the slider operations. Then only we are going to be taken into account. Suppose if you are, again that is the data, complete data which is available in the MS Word. Yes. So this time that is voltage THD and current THD. So this is the limit is added. Please see. In the last time we have going to be, it is not added in the system, but here that is what is that the THD values is to be added. So that is that the load flow analysis, which is take the difference of it, the thing we have going to be considered for the harmonic based power flow analysis, right? In harmonic, so this is that star labeling systems. If you want underground relay, way systems, switching or unswitching ground or any other ground, we are going to take into tomorrow session. We are going to take in these elements, how we are going to take as again short circuit, event based and switching based operations, right? And transients based, how the plots will be taken into account. Okay. So if you need the plot, again we have going to add the plot. There is no problem. Harmonic plots, device ID, waveforms, spectrum. Here, if you that is the cables and the cables, we are going to add the device, and then we can get that the waveform of the spectrum, specific devices. So we have added, right? So what part we have going to select it, that part we are going to be taken in this AC and DC harmonic based power flow analysis. So if you want to run the instantaneous plot as like a MATLAB, you may run this power flow, that is time domain power flow. So this is it may going to run taken as the time domain plot. So this is only given for that load flow kinetics. It's a time domain load flow analysis we are going to get, and then we are get the report and everything. What is the time period and everything we have going to get it. But this is differ from this conventional power flow. Okay. Any queries?
Hello.
Yes, yes, madam. Tell me, madam.
Sir, is it possible to get the fault data is to collect the fault data?
Yes, madam. It is. It is. There is. I think what you are expecting tomorrow. Definitely, I am going to take a class. Suppose if you are going to create the fault, that fault graph is visualized. Again, the visualized graph it will be saved as a Excel. Then Excel 2 you may going to take as any format of the data. No problem.
Thank you, sir.
Any other things? Okay, now I am going to stop this today's recording. You may get the recorded file from the